I would like to welcome everyone. This talk will be recorded. I will host it, but please ask questions in the chat. Pavel will do a great presentation on the stuff he builds around what we're doing, and after that, we'll do a quick update on what Prefix itself is working on, and I hope you'll enjoy it, and otherwise see it later on YouTube or somewhere else. Pavel, of course, if you don't know him yet, he has worked on a lot of different tools around and in Pixi and the other stuff that Prefix is building. He works at Quantco. Previously, he did masters, and while as masters, he used some of his time to also work on these awesome tools. So we'd really like to see what he has to tell about it, and I hope you enjoy it as well. So Pavel, please take it away.
Yeah, hi and welcome. Great to see so many people here. Yeah, first maybe a couple of sentences about myself. As Ruben already mentioned, I'm Pavel. I recently finished my master's in mathematics and computer science in Karlsruhe. And yeah, now I'm working at Quantco as a software engineer with a focus on deployment and internal tooling, I would say. I started at Quantco as a working student and became exposed to the packaging world in CondaForge through that, and was really excited when I first heard about Pixi. Because I knew about both Condas and Microinverse challenges that were numerous of, but I knew as well about the potential of the huge CondaForge ecosystem, and now that Pixi can finally help with that. I want to present 3 Pixi-related projects that I've been working on with a couple of colleagues. The first one is Pixi-pack, a tool that allows us to package environments to deployment. And the second one is Setup Pixi, a GitHub action that sets up Pixi on GitHub runners. There I will also present some features that you might not know yet about. And the third tool is Pixi-diff to Markdown, which is basically a small tool that allows you to update your log files in GitHub, similar to Dependabot. So let's start actually with Pixi-pack. So let's imagine that we create a super cool project using Pixi, and now we have all our dependencies specified in our Pixi toml, and Pixi has logged everything in our pixi.log file. But now we want to actually deploy this project. The obvious question now is, how can we actually do that? The classical way for this is to containerize it. So for this, we also actually have a nice Docker image, which can be found on ghcr.io/prefix-dev/pixi. But what happens if Docker is not available where we want to deploy it? So for example, imagine that your target environment is a Windows server where you want to deploy things onto, or maybe it's just a Linux machine that you can't fully control and can't install Podman or Docker onto. And for this, with the help of some colleagues, I have created a tool called Pixi-pack that helps in exactly these scenarios. It reads your pixi.log file and generates a tarball containing all relevant conda files that are required for building the package. So the file internally looks somewhat like this. We start off with a Pixi-pack JSON and a environment YAML file with some basic metadata. And the actual interesting part is what's happening in the channel directory here in this tar file. This is basically just a local conda channel with all the conda packages that we need to install our package. In order to install the environment on our target machine, we would just need to install all of these conda package in our environment, and that's it. No internet required whatsoever. Since we are only shipping .conda files and .tarbz2 files, it's actually trivial to create cross-platform Pixi packs, basically. For instance, I can just download the Windows conda packages on my MacBook using Pixi-pack, and then send the packed file, the environment tar, to my Windows server, and then just run Pixi-pack unpack on that Windows server, and everything works. CondaPack is another project that has similar goals as Pixi-pack, but it has the drawback that it always requires an installed environment that you can then pack. So if you want to pack cross-platform, this can definitely lead to some issues, as it's not really trivial to install Linux environments on Windows and vice versa. Another use case for Pixi-pack that just fell into place naturally is archiving. So imagine you found a really cool project online and want to ensure that it still works on your machine even after the inevitable downfall of the internet that we know, but you still want this project to run. Yeah, or maybe the package just gets removed from Conda Forge for some reason. And with Pixi-pack, you can just create the environment tar once and then always rebuild it, since it doesn't access the internet at all and has all files necessary locally available. Yeah, enough about the theory. Let's actually try it out, and let's hope that everything works in my small live demo. All right, so I'm in a directory. I have basically a small Pixi-toml prepared. So here we can see we have Python as a dependency and PyTorch, for example. Yeah, and what we now do, we can see we have our Pixi log file also as well. And what we can just do is run Pixi-pack pack. And then it basically downloads all of the conda packages, and then it created an environment tar file here. And if I now want to install this, I can run Pixi-pack unpack environment tar, and then I also specify the shell that I want to create shell hooks for, because I'm on fish and not on bash. And then what we can see now here is that it's installing, and here we can see we have this activate.fish file and an env directory. And the env directory is actually like our regular conda environment, and the activate.fish file basically just is our file that we would need to source in order for the environment to activate. So this is basically Pixi shell or microenv activate or that stuff. And now we can basically run Python and do things like import torch, for example, and then you see that this works even without invoking any Pixi command or any conda command. It just works out of the box without needing Pixi or conda at all. Yeah. So this is basically
Really cool.
how you can deploy it manually. And the other thing that we can maybe do is show you how to actually deploy it cross-platform. So we can run, for example, Pixi run pack, and then we can specify a platform, and then pack it to a different location, for example, to environment linux64.tar. So it does that now. Now I downloaded that. Now I have this environment file as well. And what I now need to do as well is to basically once download the Pixi-pack binary, so get it from GitHub, the GitHub releases. We now have it basically here. Obviously, since I'm on a MacBook, I can't execute it here, but what I basically now need to do is ship this file and ship this Pixi-pack Linux to my Linux target machine, and then I can unpack everything. Yeah, Torch startup does quite a lot, takes quite a lot of time. Yeah, and so this is now my target machine. It's an Ubuntu x64, so we can see here that's an Ubuntu x68-64. And what we can now basically run is Pixi-pack Linux, and then unpack environment linux64.tar. Then it's doing some unpacking and extracting all of the files. And yes, then we basically have exactly the same scenario. We have our environment and we have our activate, and we can activate everything. You can see that our Python is exactly the right Python that we want, and yeah. Now we can also import Torch again, but yeah, as Julian already mentioned, the startup times, actually they are here quite fast. Yeah, so this is basically Pixi-pack in a nutshell, how it works. Any questions so far?
Yeah, that's awesome, Paul. Thank you for showing the real life demo. That always helps. I had a question that are you already using this in some production environments, and how is it received?
This was actually the original motivation for it. We tried out CondaPack at first, and there were some reproducibility issues and some flakiness and some errors involved, and then we just decided to rewrite it in Rust, and now it's I think it's not deployed yet, but it's definitely on the being used and already tested.
Amazing. It's great.
Do you think this would? I think it will, but do you think it will also be a solution for environments that don't have access to internet? Like you could even bring it on the USB stick, right?
Yeah, you can bring it on a USB stick or get it somewhere in some way to there, and then work with that.
Nice.
I was wondering how your experience with Rust was, and if you liked the interfaces of Rattler, or how that went.
Yeah, the I would say the interfaces of Rattler, we basically, I mean, the code is not that large. It's maybe like 400 lines of code. Most of the heavy lifting is luckily done by Rattler, so we didn't really need to implement a lot of stuff. So I can recommend just using the Rattler library. It was very fun to work with.
Cool.
All right. Now that I have presented Pixi-pack, let's talk about another project that I've been working on, namely Setup Pixi. It's basically the go-to way to set up Pixi on GitHub runners. First a quick overview. What does Setup Pixi actually do? So it obviously installs Pixi. It then can also authenticate with Pixi to anaconda.org, for example, or to Quets, or to Artifactory, or to prefix-dev, for example. So basically to all of the conda channels that you have available, you can authenticate with some custom parameters that we can see here. It also supports automatic caching for your environments, and we already tested it out quite extensively on self-hosted runners, and it works well there as well. Okay, so first let's quickly take a look at how the action output looks like. So we can see here that it's separated into different collapsible sections depending on what's currently happening. So we see at the beginning it's downloading Pixi, then it's trying to restore the cache, then it's running actually the Pixi install part, and at the end you can see that it's also running Pixi list, which I personally find quite useful because then I can see directly the package versions that I have installed. Caching of the .pixi directory is also active by default, and the cache key that's being used with GitHub Actions caches is based on a couple of factors, the most important ones being the pixi.log file. So as soon as your log file changes, your cache is automatically invalidated, and Setup Pixi will create a new cache. Another thing that I think is great, a great default in Setup Pixi is that Pixi install runs by default with -- logged. So if you accidentally not update your log file, Setup Pixi will automatically fail and tell you, your log file is not up to date with your project. Please update your log file in order to ensure maximal reproducibility. Another thing that you might not know about in GitHub Actions are custom shells. So you can theoretically specify anything in these shell parameters. And what GitHub does is it basically creates a temporary file with the contents that you specify. So for example here with python -- version and pip install in this file. And then it basically runs the shell with the file as the parameter where you see the 0 in the brackets. And basically nothing is preventing us from just putting pixi run bash in the shell part, for example, which then will execute everything that you specified in the Pixi environment. And you might have also heard about Pixi exec in the latest release notes. It's a new feature that allows you to run one-off commands in temporary Pixi environments. So this can also actually be put in the shell parameter, for example, in your GitHub workflow. For example, if you want to run some very simple Python script that requires the PyYAML dependency, for example, but you don't want the extra overhead of creating an environment and installing PyYAML in there, you can basically just specify the dependencies in the shell parameter using Pixi exec, as you can see here. And the last feature of Setup Pixi that I want to talk about today is the activate environment flag. So if you maybe find it a bit too tedious to specify a custom shell in every command that you run and don't want to prefix everything with Pixi run, You can also just specify activate environment to be true here in the setup Pixi action. And what this then does internally is it checks the environment variables that would be set on Pixi shell and forwards them to the subsequent steps of your workflow. And yeah, that's basically setup Pixi. And the last tool that I want to talk about today is Pixi-dev to Markdown. So imagine you now have your CI set up perfectly using setup Pixi and your project works great and all. But you now want to ensure that your project also works with newer versions of packages that come around. Yeah, there has been actually some open issues for both Dependabot and Renovate to include the Conda ecosystem. Unfortunately, nothing has materialized out of this yet. So this is basically why I wrote my own tool that can help with this. It's called Pixi-dev to Markdown and can generate these Markdown tables here that tell you what happened after you executed Pixi update. And for projects with a lot of different environments and platforms, for example, if you want to test against different Python versions, it even merges the updates in order to make the summary as readable as possible. So you can see here, for example, MyPy updated from 1.10.1 to 1.11.1 in a lot of environments, namely the default and the Pi 3.12 environment, and also on all platforms. So this makes the Markdown summary somewhat actually readable instead of having hundreds of lines of actual summary code. Yeah, it's actually pretty straightforward to create a GitHub workflow that automatically updates the PRs. So the workflow looks roughly like this. So you first run pixi update -JSON, ideally also -no install, because you don't need to install the environment on your machine, and pipe this output to pixi exec diff to pixi-dev to Markdown. So you basically just run this tool here and output this part to the diff.md file. And then you can just create a pull request using this GitHub action, for example, and specify the body path to be this Markdown file with a diff, and say that you only want the pixi.log file to be present in the PR. Yeah, and basically, yeah, that's basically it. What you need to do to have this up to date. Yeah, you can actually find the full example in the official Pixi documentation. Yeah, that's basically it from my side. To summarize maybe the tools that I've presented. So Pixi-pack can easily create reusable tarballs that can be installed anywhere for simple deployments. Setup Pixi is a GitHub Actions with lots of convenience features, and Pixi-dev to Markdown can be used to generate Markdown summaries for Dependabot-like PRs in your projects. Here are also the GitHub repositories for the tools that I've talked about. Yeah, let's see if there are any questions.
Thank you, Pavel. It's really good to see them. And also, just to mention for the rest of you guys, these are all built by Pavel, but for instance, Setup Pixi is moved to the prefix organization, but still heavily maintained by Pavel. We help with maintenance, but this is definitely mostly coming from Pavel and his colleagues.
Yeah, so I saw a question from Travis. What is the game plan for maintaining Setup Pixi? How many people are currently involved in feature development and bug fixes? Yeah, I mean, I would say, yeah, I did most of the stuff implementing everything, but there have been a couple of people from Quantco mostly that also helped with implementing new features and bug fixes. Yeah, I would say at least now it's sort of feature complete, and there's not really much to be done except for maybe adjust a couple of CLI flags if Pixi decides to adjust their interface. But other than that, yeah, I don't know. I can imagine myself continuing to support this for quite some time.
We will obviously take over if that would be the case at any time, because this is such a valuable tool to us. This is, of course, definitely also our responsibility. That's also why it's under the organization of Prefix. Are there any more questions for Pavel?
Yeah, I would add one for also set up Pixi. So yeah, so I'm using it a lot and it's great. But sometimes I see that if I am using the cache, that the cache is sometimes slower than downloading the Conda environment directly. So we also use Artifactory. I think it's environments around 300 megabytes. So I was just curious if someone in this call experienced the same thing, that actually loading the cache is sometimes slower than downloading the Conda files directly.
I mean, there was an issue where uploading to the cache took a lot of time. This was basically some GitHub internal issue from the GitHub toolkit. Downloading, I didn't have that issue yet. I mean, you can always deactivate the cache, but yeah, for my experience, from my experience, the cache was always a bit faster than actually downloading it from Pixi. But yeah, the difference was with setup micromember, or if you run it with Conda, it was much larger. That's definitely true. But from my experience, at least, yeah, Pixi was always a bit slower than just downloading and extracting the cached file itself.
I do think that, I don't know when you started using Setup Pixi, but at some point there was a bug fix release basically where the upload times for the cache have drastically improved due to that bug that Pavel mentioned. But yeah, not sure if you are affected by that.
I mean, it could be interesting to actually see what's happening under the hood if you do this cache unpacking. Because what I think is happening is that it's just running extracting the tarball and downloading it from GitHub. I would imagine that extracting a tarball should be fairly similar to what Pixi does. Yeah.
One benefit of Pixi is that it will download multiple files in parallel and also extract them in parallel. So that could be a slight advantage depending on the implementation of how GitHub downloads and
Could look
extracts.
into that at some point.
Yeah. So just to clarify, so I'm not saying it's slow. It's probably, I think the whole action for me took like 10 seconds. And sometimes it's basically 10 seconds cached and sometimes like 8 to 9 seconds not cached. So it might be that even those little ones with downloading in parallel just make the difference.
Yeah.
Yeah, it can be sometimes slower, but that's already crazy speed, I would say, for 300 megabytes. If those were the questions, I would like to continue with some other information on Pixi. So thanks a lot, Pavel, for showing what you've done over some time. I know there's more, so maybe we can do another show and tell later again. To get back to what we're working on for Pixi itself, the team currently is doing a big deep dive into two different topics that I want to quickly mention. I'm going to share my screen. This one. I hope you can all see it now. Give me a thumbs up, please. Anyone? Great. So the first one is we're working on an improvement of Pixi Global. There's a proposal in the pull request now, the same way we did a multi-environment feature. We're going to do it for Pixi Global now, and there's a rendered version that you can all look at, and you're very welcome to give your feedback. We're currently still in the discussion within the prefix team on how we want to do it, but yeah, good feedback is always welcome. Some of the plans are adding a manifest and allowing you to share your work between machines or colleagues, just to give a few ideas there. But please read it if you want to know more and get yourself involved. And the other topic that we're going to work on is Pixi Build. This is something we promised since the start of Pixi, actually, but we finally made it into an actual prototype, or at least we're building on that. For this, we did a huge refactor of a lot of the internals of Pixi. We pulled out a lot of the stuff into crates, so you will be So you will be able to reuse some of the Pixi work separately from the full Pixi. For instance, reading the manifest and soon also reading the complete project and getting some information out of it. We're still working on that. The deep dive is still going, but I hope to be able to share some initial work soon. And I hope that informs you a little bit more on what we're building. There's no big features that we've recently released, so I would like to continue to the other stuff we've been working on, which is the Conda Forge Rattler build update, and Wolf will tell you a little bit more about that.
Yeah, I don't have anything to show yet, but we're very close to have everything merged into the Conda Forge infrastructure. So we had a few big PRs and CF scripts that needed to be done, and Matthew Becker has helped us a lot in like moving them forward and merging them and reviewing them. And Conda Smithy also got a few new linter rules for the new recipe format. So things are looking pretty good. And we were hoping to be able to sort of merge the first recipe to staged recipes today. Not sure if we can make it because we do need a release of Conda Smithy. But yeah, that's where we are currently. And ideally everything should be going over the next weeks and first recipe YAMLs popping up. The upload to the main channel is still disabled, so we cannot really like publish the new builds yet, but it's step by step, and I think it's happening. So we are really excited about it.
Definitely, thank you, Wolf. If there's any questions, please either speak up by unmuting or in the questions chat. And if there are none.
Maybe one question to the last topic. So I would assume that this changes are non-breaking. So if I still want to use Conda or Micromamba for some reasons, they would still work. Regarding the new recipe format, if I'm a maintainer of feedstock library, so I can still use the old one and migrate whenever I want to, or how is the migration?
Yeah, so that's a good question. It will be purely opt-in, at least for like a very long transition period. So it will be just if you have the meta YAML in your feedstock, Conda build is going to be used. If you have a recipe YAML in your feedstock, then Rattler build is going to be used. Maybe at some point, but this is like completely not clear at this stage. We would have some sort of automatic translation of recipes from meta YAML to recipe YAML, and then maybe automatic PRs. There's a project by Anaconda that's called Conda Recipe Manager, and it does have a conversion function. So it can take a meta YAML and spit out a recipe YAML. It works pretty well for like your average like standard recipe. There are definitely edge cases where it's super non-trivial to convert it. But yeah, that is our current approach to this. So a very gradual migration. And Micromamba, Conda, anaconda.org, Quets, and everything is compatible with like the output of Rattler build. So on the client side, or the people that are installing packages, nothing changes at all.
That was a good question. Thank you. Is there anything else? I see that Travis asked, do you need volunteers to help with Conda Forge Recipe V1 projects? I have a couple of projects on Conda Forge. I could switch to using the new recipe format.
I think if you like, even just trying it locally, like converting a recipe, running Rattler build, seeing if things work, maybe looking for some edge cases or tougher things. Any of these things would be super appreciated, and filing issues is also super appreciated. So yeah.
Great. Anything else from you guys? Trevor says, cool, this will give me a good excuse to check this stuff out. That is, I think, concluding for the show and tell. I would like to thank Pavel again for his great presentation. It was really good to see it from his side. And you all for joining. This will be uploaded to YouTube afterwards. And yeah, hope to see you in some of our next show and tells. Thanks again. See you.